We're going to look at hyperbolas, which are different than a hyperbole, which is in English, where you're exaggerating a point. A hyperbola is a shape. So a hyperbola is the set of all points in a plane. The differences of whose distances from two fixed points, called foci, is constant. So if we look at this picture here, this is the shape that creates the hyperbola. Okay. So here's a focus and here's a focus. So it's kind of like two parabolas. Okay. So if you take the difference of these two from the point on the hyperbola to the different foci, that difference is the same. So we create this very similar to how we do our ellipses. So notice on our ellipses, our equation for ellipses was that we had, almost there we go, that we had something squared divided by something, something squared divided by something equals 1. And we were adding the two of them together, which was different than our circles where we had something x something squared, y something squared, added them together and it equaled r squared. So it wasn't being divided by anything. Okay. For our hyperbola, if we look at our equation, instead of adding, we're subtracting. Okay. So it's that same kind of setup as an ellipse, except for instead of adding, we're subtracting. Again, we have two forms here. You could have, so your hyperbola is oriented so the parabolas are opening, the parabola-like shapes are opening sideways, or you could have where they're opening up and down, right? So wherever the parabolas are opening towards the x, whichever axis it's opening towards, so these blue ones are opening towards the x-axis, that means that the x is first or positive and the y is negative. If the y is positive, then it's opening up and down. And if the x is negative, then it's opening up and down. Okay. You find your center the same way, but on this one, instead of creating, you find your vertex and your co-vertices the same way that you do on an ellipse. So the only difference between an ellipse and a hyperbola is how you draw it. Okay. So here, these 4 points would become your ellipse, and instead we make this little box here, and then we create asymptotes that go through the corners of the box through the center, and then those create asymptotes, and then this vertex is a point on your hyperbola, and then it follows your asymptotes. Okay, same kind of thing here. Here's your vertex. You've got your co-vertices, you make this box, you put your asymptotes through it, through the corners of the box and the center, corners of the box and center. And then you have your vertex, and then you pull towards your asymptotes, vertex and pull towards your asymptotes. Okay. We find the C value in the very same way, or not in the same way, close to the same way. So this is where it looks like our Pythagorean theorem. Okay. So before, our foci and our ellipse were on the inside of the box or the inside of the ellipse. Here the focus or the foci are on the outside of the box. So notice this is a squared plus b squared. So the hyperbola is adding in between for the c, squared equals a squared plus b squared, but subtracting on your formulas. And on the ellipse, it's adding on the formula or the equation. And then to find c squared, you're subtracting the a squared and b squared. Okay. So let's take a look at our examples. Okay. So this gives you a detailed information as to what I'm going to go over. Actually, it gives you a couple extra pieces of information. So here, our center is located at 0, 0. That's because there's nothing in here and there's nothing in here. So we're just located at 0, 0. Now here, since the x squared is positive, whatever's positive is what shows which direction it's going to be opening towards that axis. So since the x is positive, it's going to be opening like this. Now, just so you are aware, I could write this equation as negative y squared over 36 plus x squared over 16. So it's not always the thing that's first. It's really based off of what's positive or what's negative. Okay, so pay attention to that detail. So we're starting at 0, 0. we find the same thing to get our vertices and our co-vertices. So this is a squared, or this one's a squared because it's bigger, and this one's b squared. So we have, I guess in this case, they don't actually care about a squared and b squared. Yes, they don't care about a squared and b squared on this one. It just makes a difference on the ellipse one. So we have a squared is 16 and b squared is 36. So that means a is 4 and b is 6. So here I know that this one, the 16, goes with x because it's below the x. So I'm going left and right by 4. So 1, 2, 3, 4. 1, 2, 3, 4. And then our b squared is under the y, so it goes up and down by 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to create a box with dotted lines. And then I'm going to create asymptotes that go through the corners of that box. I should have dotted that. And through the center. Now, it is important, so it's not based off of which direction it opens as to which one is taller or which one is wider, right? So on our ellipse, this one would be taller, right? But that's not based on where it opens. So whichever one is positive is where it opens. So since the x squared is positive, our hyperbolas open towards the x-axis. So these are our vertices, and these ones are our co-vertices. So I'm just going to start here, and then I pull towards the asymptotes, pull towards the asymptotes. And that gives you your hyperbola. Now we also can find the foci. So our foci are from the center, and then we add our c value. So we first have to find the c value. Well, for hyperbolas, the equation is a minus. So inside the c squared, it's a squared and b squared added. So these signs are opposite of each other. So then we're just going to do 16 plus 36 equals c squared. So if we do 16 plus 36, that gives us 52 equals c squared. So c is the square root of 52, which is 2 and 26, and 2 and 13. So that gives us 2 root 13. Okay. So if we go to put 2 root 13 in the calculator, that gives us 7.2. Okay, so we know this distance is about 7.2. So we've gone over by 4. 5, 6, 7.2. 5, 6, 7.2. And then those are the foci. And usually they subscript them as 1 and 2. Now, we want to find those exact values. So we go from our center, and we go from our center to the left, and from our center to the right. So we're changing our x value of the center. So since our center is 0, 0, that means that our foci is going to be positive or negative 2 root 13, sorry. And then keep the y value. So we did 0 plus or minus 2 root 13, but in this case, since we're just at 0, then it's really simple to do the addition. Okay. Now, if we look at this one, we're subtracting, but nothing's being divided and it's not equal to 1. So what I'm going to do in order to set it equal to 1 is I'm going to divide by 64 on each one of these. So if we divide by 64, we divide by 64, we divide by 64. So then this gives us y squared over, and then 16/64 reduces to 1/4, so over 4. And then 4/64 gives us 1/16, so x squared over 16 equals 1. Okay. So here, this is centered at 0, 0. And then a squared is always on your hyperbolas are always defined to be the first one, or the positive one, I should say. And then the b squared is the negative one. Oops, I'm pointing to the wrong spot. So here and here, so our a squared is 4 and our b squared is 16. So a is 2 and b is 4. So I always just remember what it's underneath. So this is underneath the y, so we're going up and down by 2. And then we're going left and right by 4. Again, the way that we determine which way it's opening, the hyperbola is opening, is based on which thing is positive. So our y squared is positive in this case. So then that means that we're going to be opening up and down. So I create my asymptotes through the edges of the box, or not the edges, the vertices of the box, or the corners. And then you go through the center as well, is what I'm trying to say. So then we're opening up towards our y's, since y is positive. So here's my vertex, and then I'm going to pull towards the asymptote, pull towards the asymptote. Here, pull towards the asymptote, pull towards the asymptote. Okay. Let's try one that's not centered at 0. Oh, I didn't find the foci. Okay. So if we find the foci here, our c squared value is going to be 4 plus 16. So c squared is 20. So then c is the square root of 20, which is 4 and 5, so 2 root 5. Okay. So if we find 2 root 5, whoops, not how I wanted to write that, 2 root 5, it gives us 4.5. So 1, 2, 3, 4.5. Oops, I went the wrong direction. 1, 2, 3, 4.5. 1, 2, 3, 4.5. So your foci are inside of your hyperbolas, right? So I had originally gone this direction, which is not correct. So here our center is still at 0, 0. So we're going to go left and right by nothing. So our foci are located at 0. And then we're going up and down by our c value, which is 2 root 5. So plus or minus 2 root 5. Now let's try one that's not centered at 0, 0. So if we give you this one here, we're going to do the opposite of inside the parentheses, opposite of inside the parentheses, just like we've done for circles and for ellipses. So our center is located at negative 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7. Okay. Oh, positive 7. 1, 2, 3, 4, 5, 6, 7. Okay. So now that we have our center at negative 5, 7, underneath the x's, we're going the square root of 32. So the square root of 32, that's 4 and 8. It's 4 and 2, so that gives us 4 root 2. So numerically, if we do 4 root 2, that gives us 5.7. So that was under the x's, so we're going left and right by 5.7. So 1, 2, 3, 4, 5, and then almost to 6. 1, 2, 3, 4, 5, almost to 6. And then underneath our y is 16, so that's our b squared. B is 4. So since that is under the y, we're going to go up and down by 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we make our box. And then we make our asymptotes that go from corner of the box through the center through the other corner. And then we go look and see which one's positive. Our x squared is positive, so it's going to open towards the x-axis, so it's going to be this direction. The other way that you can remember is that the x is open left and right, and the y is open up and down. That's another way that you could look at that. So now let's look at finding the foci. So if we're going to find the foci, we want to find the c value. So we're going to do c squared is 32 plus 16. And since we are on a hyperbola and there's a minus here, there's a plus here, so then that gives us 48. So c squared is 48, so we take the square root of that. That's 4 and 12, which is 4 and 3, so we get a pair of 4s and a 3. So 4 root 3, which gives us 6.9. So our foci is from the center, left and right by 6.9. So 1, 2, 3, 4, 5, 6.9. So there and there. Okay. And then we want to find our precise value of that. Now, to find our exact value, we have to go left and right from our center. So we're going to use our center, and since we're going left and right, we're going to use our x value left and right by the c value. So we're going to take our foci is -5, and then we're going to add and subtract 4√3, and then our y value remains the same, which is 7. Okay. So then this is where our foci is located. Okay. Now, we can also do where we have it in our general form, and we want to get it to our standard form. So we have to complete the square on the two different parts. So we're going to have group your x's, group your y's, just like we did with the ellipses. So 9x squared minus 36x, and then plus, oh, just kidding, it's a minus, minus 16y squared minus 64y, and then plus 116 equals 0. Okay. So when we take the 9 out, remember there's something in front of the x squared that you have to divide out of both of these terms. So 9x squared divided by 9 is x squared. Negative 36x divided by 9 is negative 4x. Plus blank minus blank. And then here with our y squared, notice there's a negative in front of here. So I'm going to factor out a negative. So you do have to be really cautious of your negative. So when I take out my negative 16y squared divided by negative 16 is positive y squared. Negative 64 divided by negative 16 is a positive 4y. And then plus blank minus blank. And then we still keep the plus 116. Or you could move the 116 to the other side. It won't make a difference right now. So then we finish completing the square on each part. So negative 4 cut in half squared. So that gives us negative 2 squared, which is 4. But we really did 9 times by 4. So when we do 9 times by 4, we were really adding 36, so we have to take away 36. Okay. When we look at the y's, we take the 4, cut it in half, squared, which is 2 squared, which is 4. But we were really doing negative 16 times 4. So when we were doing that, that's really negative 64. So I'm going to subtract a negative 64. Whoops, I missed. Which means that this will flip and be positive because we were subtracting 64 here, so we have to be adding 64 here. So our 9 stays factored out in front. We get x minus 2 quantity squared. Remember, it's the thing before you square it, or you are factoring this part, so it multiplies to 4 and adds to negative 4. I'm going to hold on the minus 36, and I'm going to combine that with our 64 and 116. I'm just going to change that so it looks more like a 4 instead of a 9. And then the negative 16, I'm going to keep that out. And then y plus 2 quantity squared. Remember, again, it's the thing before you square it, or you're factoring this, so it multiplies to 4 and adds 4, so that's 2 and 2. And then we've got negative 36 plus 64 plus 116. So we do negative 36 plus 64 minus 119 plus 116. No, 116. Gives us 144. So this equals, not equals, plus 144. That equals 0. So remember, we want this to equal 1. So I'm going to move the 144 to the other side. So then that gives us 9 times x minus 2 squared minus 16 times y plus 2 squared equals negative 144. If I want this to equal 1, that means I have to divide by negative 144. So notice, originally, our 16 with our y's is what's negative. But right here, when we get it to set equal to 1, it's going to flip it and it's going to make the x be negative. So divide by negative 144. So if we do 9 divided by 144, and you can math frac it on your TI calculator or do the fraction button on this one, so 1/16. So this will be negative x minus 2 squared over 16 plus, and then if we do 16 over 144, that will give us 1/9. So then that gives us y plus 2 quantity squared over 9, and then negative divided by negative is positive, so 1. Okay. So now this looks a little different. You can reorder it if you would like and say that this is y plus 2 quantity squared over 9 minus x minus 2 squared over 16 equals 1. And then it looks more like a normal one. Okay. Now if we go to graph this, our center, just going to use this space down here, we're not going to use this problem right now. So our center is at negative 2, pause, nope. Oh, I bet I did that wrong on a whole bunch of them. 0, 0, negative 5, 7. Oh, conveniently I did not. Oh, good. This is something to be careful of. So notice here, when, oh dear. Just doing all sorts of crazy things. Notice here I went negative 2, positive 2, but notice this is your x value, this is your y value. So you have to be really cautious of that. So this is your x, this is your y. So we're doing the opposite of inside here, which is positive 2. And then we're going to do the opposite of in here, which is negative 2. So just conveniently, I happened to not make that mistake above, which is great. And then we mark our center, so 2, negative 2. And then underneath the y's, we're going left and right by 3. 1, 2, 3. 1, 2, 3. And then up and down by, nope. I did it again. This is the y, so up and down by 3. I don't know if I had said that. 1, 2, 3. 1, 2, 3. And then this is underneath the x's, so left and right by 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, sorry about that. So I create my box. I'm just going to double check I didn't mess it up anymore. We went down 2 here, right 2 here, up and down by 3. 1, 2, 3. 1, 2, 3, left and right. 1, 2, 3, 4. There we go. Okay, so you do have to be cautious of that when your y's are in front, that you take the x to be in the x spot and the y to be in the y spot, even though it's out of order. Okay. So some of you may prefer to have it written this way so that you don't keep making those mistakes that I had just made. So we make our asymptotes here. It's not as pretty because it's not on a graph. And then since the x is negative, that means the y is positive, so it's opening up and down or going towards the y-axis. So we get our hyperbola here and our hyperbola here. So that's our graph. And then if we find our foci, we need to find our c value. So our c squared is a squared plus b squared, so our 9 plus 16. So then that gives us 25 is c squared, so then our c is 5. So from the center, I'm going to go up and down by 5. So then since our center is at 2, negative 2, since we're going up and down, I'm only going to change the y value. So I'm going to do negative 2 plus 5 and negative 2 minus 5. So we can simplify those. So negative 2 plus 5 gives us 3, and negative 2 minus 5 gives us negative 7. So then our foci is at 2, 3 and 2, negative 7. If we go and graph that, we would go from our center and we would go up by 5. So 1, 2, 3, 4, 5. Goodness gracious. And 1, 2, 3, 4, 5 here, and those are the foci. Okay. So that is what gets us our picture when it's in general conic form instead of our standard form that you can read the center off and find how much you're changing on the x's and how much you're changing on the y's. So again, make sure that you're really careful when you're grabbing your center that you put the x with the x point and the y with the y point, regardless of which order they are in.